All right. I'd like to start things off by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And of course, today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models, including the very latest models incorporating new cutting-edge technologies. Now, over the years, I would typically begin these presentations with a discussion of the importance of STEM education and talk about changes in the manufacturing environment, and of course, the growing need for highly skilled workers in the modern workforce. But really, at this point, I think it's pretty well established just why technology-focused education is so necessary. And so we're going to pretty much dispense with a lot of that preamble and jump right into the discussion of what fischertechnik is. And then I'm going to show you each of the current models that are available in the simulation family. And of course, we'll get into the details on them. fischertechnik simulation models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate in both appearance and function various automated robotic machines and systems that are commonly used in commercial manufacturing. Now, before we begin to look at each of these models specifically, I'm going to provide you with just a little bit of background in fischertechnik as a whole. fischertechnik has been creating tools for teaching students of all ages about how technology works for nearly 60 years. Actually, it's 60 years at the end of this year. And it's all based around their unique building system. Now, what makes the building system unique is that unlike other popular construction sets where the blocks are designed to simply stack, in the fischertechnik system, it was created with more of an engineering mindset. The core building block used in the system is designed to enable attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Many of the parts in the system are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different, very specific parts that are available will also help technical builders to address equally specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who's seen on the screen now, and he's noted for countless innovations used in both the construction and the automotive industries. At the time of his death in 2016, Mr. Fischer held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. For example, prior to creating fischertechnik, Mr. Fischer was first noted as the inventor of synchronized flash photography, and this was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices used in building construction. And they also, up until recently, have produced numerous components used in the automobile assembly plot process. And now they're also known for providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik building sets, and it's whether those that are intended for the retail market that might be labeled as quote unquote toys, or those that are designed for classroom use. The focus throughout has always been on helping to foster an understanding of technology. Now, many of the products offered by fischertechnik specifically for the education sector are what we would call subject-specific sets, and they usually focus on different STEM-related topics, things such as mechanics, pneumatics, robotics, renewable energy, topic areas such as this. Now, in the case of these sets, most often they either have some sort of curriculum or some sort of detailed teaching and activity materials included. And in most cases, students are going to be asked to build a progression of models as they use each of these kits, using again the unique fischertechnik building system. And then they perform various experiments which would allow them to explore and understand key aspects of the subject being studied. Now, the line of fischertechnik simulation solutions, which again are the focus of our presentation today, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models which are designed to again replicate in appearance and function various automated robotic machines and systems. Some of the types of things you're going to find in the fischertechnik simulation line will be things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high-bay warehouse storage systems. Now, besides these individual models, which of course will focus on specific automated processes, Fischer Technic also offers several variations of essentially what's an integrated factory simulation model. In the case of these factory simulation models, which you'll most commonly find are four or more individual workstations, most often a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection that are designed to all work together as one self-contained material cycle. Now, we're going to, of course, look at all of these factory models and some of the more involved factory models a little bit later in this presentation. Now, before we get into any of that, I'm going to very briefly outline some of the advantages of using fischertechnik simulation models. First off, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or for having a tangible physical system to observe and work with when you're involved in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, and that's again in both appearance and function, common automated systems. Again, things like conveyor belts, sorting machines, robotic arms, and much more. Now, because the models are compact and in most cases tabletop size, they're not only ideal for use in the classroom or in-office demonstrations, but they're also great for demonstrating software or other technology-based offerings in a trade show environment. Of course, quality is a big factor. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each model is available in a 24-volt version for industrial users, with select models also available in 9-volt versions for those not versed in the use of PLCs or those not focused on PLCs and programming. In the case of the 24-volt versions, they are designed to be used with industry standard PLCs. Now, it really doesn't matter whether you prefer to use Allen Bradley controllers or Siemens controllers, or if you use controllers from manufacturers like Honeywell or Mitsubishi, General Electric, etc. You should be able to control these 24-volt models with the PLC that you prefer. Likewise, you can choose from among the most popular programming languages to do the programming for this. Now, do note that with most of the 24-volt versions we're going to be talking about, there will be exceptions, and I'll note those, but with most of these, there's not a PLC included, and there's not going to be the wiring that would occur from the model to the PLC. So know that in most cases, except of course where I mention otherwise, you are going to have to provide that, the wiring, the PLC, and of course create your own programming, depending on what your preference is and what you're using. Of course, in the case of the 24-volt models, we don't think this should be an issue, as these, again, are designed specifically for industrial users or for those who are teaching and exploring industrial processes involving PLC programming. Now, as I did touch on, there are also 9-volt versions of select models that are available. And in the case of these 9-volt versions, they will ship pre-wired to fischertechnik's own proprietary robotic controller, which is the Robotics TXT controller. And in the case of these 9-volt models, they'll also come pre-programmed, most often using fischertechnik's own RoboPro programming software. There's a couple of exceptions where they use C++, but we'll get into that as we mention them. Now, in the case of these 9-volt models, the only additional component that you would need is you would need to buy a power adapter for them. In some cases, you may need up to 3 power adapters, depending on how elaborate the model is. Again, we'll address that as it comes up in the case of each model, but otherwise, everything else you need with the 9-volt version should be right there in the box. Just the power supply, and then you're good to go. Now, the next advantage. Now, if you're involved in demonstrating or exploring IoT, which is, of course, the Internet of Things. Now, besides the fact that many end users have adapted models in the primary line of simulation and training models for IoT purposes, since then, fischertechnik has also begun offering special IoT-focused versions of the factory simulation, which are designed specifically for exploring and understanding cloud-based control and what is often referred to as Factory 4.0. Now, in the case of these models, the model is designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to get into the details on that as we address those specific models. Finally, fischertechnik simulation models are cost effective. Now, if you've had the opportunity to shop around at any of the other hardware-based industrial simulation options that are available in the marketplace, and there are some very nice ones, you'll also notice that the price can get quite high very quickly. A lot of times you're talking about an entry point of 30, 40,000 dollars or more, and it can easily go up to 100,000, what have you, depending again upon what you're talking about. Now, fischertechnik simulation solutions, on the other hand, start out at just a fraction of that price. Yes, we have some that can get pricier, but your entry point is very low. And even at the high end, they're still less than the other things we were just talking about. And again, they're compact, they're realistic, and they're high quality learning and demonstration tools. So with that being said, let's begin looking at each of the models which are currently available. Now, we are going to begin with a look at some of the more basic modules, and we're going to work our way up to things like the larger factory models that I touched on again, where in that case where you have several workstations that are designed to showcase an entire production cycle. So we're going to start off with the classic line of fischertechnik simulation models, and the first one we're looking at is a very basic conveyor belt. Now, this is a transport belt with a length of 275 millimeters that's used to transport work pieces with a diameter of up to 29 millimeters. Excuse me, up to 29 millimeters. Now, if you so chose, multiple conveyors could be connected to whatever length you might need, and there is in the details, they'll tell you how to do that. It's easy enough to do with a few extra parts. Components on this model include an excess motor, a push button limit switch, two photo transistors, and two LED light barriers. The dimensions are approximately 14 by 10 by 4 inches and has a weight of just about 10 pounds per unit. It is available in a 24-volt version with a multi-pin connector, 26 pins with a 2.54 millimeter grid, as is shown here. And again, the 24-volt version of this model, as well as many of the 24-volt versions we're going to look at in the early part of this presentation, again, will require you to provide the wiring from the model to the PLC connection board, PLC, of course, and the programming. There is also a 9-volt version, which is connected to a pre-programmed robotics TXT controller, as shown here. There is one power adapter is required for operation, so you will have to get that. I will mention that for this and for all of the models that we're going to look at today, the specs are also detailed on the products listings found on both the Studica.com website and the fischertechnik.biz website that we maintain, as well as in our product brochure. Which again, if you need to obtain any of these things, I'm going to give you some information at the very end so you'll know who to reach out to access that. So if you need documentation on these things or copies of brochures or catalogs, you can connect with us. Next model we're going to look at, we're skipping this one because it's no longer available. So pretend you didn't see that. It's already sold out. It's gone. It's been replaced with other models we'll get to. The next model then we're going to look at is the indexed line with two machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station and four conveyor belt sections. Other components on this model include 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches. It has a weight of about 11 pounds. This is a limited availability model. Just like the one that we just flipped through, this one is going to be disappearing soon because it is being phased out. So know that if this is something you want, it's limited to stock on hand. So probably reach out sooner than later. But again, it's available in a 24-volt version currently with a 26-pin connector and a 2.54 millimeter grid for use with PLC. Same variables as I mentioned before with providing your own programming, etc. And the 9-volt version, which comes wired to the pre-programmed robotics TXT controllers, in this case, 2 controllers, and you will need 2 power adapters for that to work with that. Next up, we are looking at a variation of on the idea of a pick-and-place robot, and they call it the 3D or 3-axis robot in this case. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely Position the workpiece as it picks up in three-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters, and axis 3 can raise or lower 150 millimeters. Excuse me. Components on this model include two excess motors, two encoder motors, and four push-button limit switches. The dimensions are approximately 19 by 16 by 9 inches, and it has a total weight of about 6 pounds. Now, again, as with the other models we've looked at, it's available in a 24-volt version with the 26-pin connector and 2.54 millimeter grid, designed for use with the PLC and programming of your choice, or a 9-volt version, which is wired to a pre-programmed robotics TXT controller and does require the 1 power adapter. The next model we're looking at is a vacuum gripper robot. And in this case, you don't have to just keep looking at the slides. You're going to get to start seeing some video here. Now, as you're going to see, the vacuum gripper is, again, a variation on the 3-axis robotic model with except with a vacuum gripping device built onto it. Again, the model is designed to precisely pick up and position workpieces in three-dimensional space, this time utilizing the vacuum gripper instead of the pinchers. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The dimensions for this one are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt version of this model, as well as the 24-volt versions we're going to be looking at moving forward in the presentation, each have a relay board for motor polarity reversal and both a multi-pin connector, in this case, 34 pins with a grid of 2.54 millimeters, if that's of importance to you, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all of the 24-volt versions we're looking at so far, require you to provide the PLC and the programming. We'll let this play through. And yes, just to note, there is not a 9-volt version of this available. And all done. The next thing we're going to look at is the automated high bay warehouse. Now, this model that you're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays. And it also has 9 individual storage spots for the workpieces in their carrier trays. Components you're going to find in this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each piece. One thing I always mention about this model is that it's a favorite among educators who are involved in teaching PLC programming, specifically because it gives students a lot of very specific coding tasks to address, especially in this area right here. The retrieval and entry of the work pieces in the carrier trays into the slots, which of course requires very specific coding tasks because of the precise movement of the picker arm, etc. So this gives them a lot of meat to work with as far as programming. Getting back to the dimensions. Dimensions of the model are approximately 19 by 28.5 by 15 inches, has a weight of about 18 pounds. Again, 24-volt version. I know I'm running longer than the video. Has a relay board for motor polarity reversal and a multi-pin connector. Again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. You provide the PLC and the programming. There is still a 9-volt version available, which ships pre-wired to the TXT controller, and you require a power adapter for that. Okay, next model is the multiprocessing station with an oven simulation. And what you're going to see here is essentially a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components you're going to find in this model include four mini motors, six push-button limit switches, two phototransistors, two LED light barriers, four solenoid valves, and a compressor. The dimensions of the model are approximately 20 by 14 by 12 inches. It has a weight of about 11 pounds. It is, of course, available in the 24-volt version, which you use again with the PLC and the programming of your choice, which once again has a relay board for motor polarity reversal and both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeter, uh, as well as additional PCB terminals with pushing connections for all inputs and outputs. The 9-volt version, as you can probably see from the video, has two robotics TXT controllers connected to it, so you would require two power adapters for this one if you purchase it in the 9-volt version. We'll let this play through a little bit. And dropping off. The next model we're looking at is the sorting line with color detection. And what you're going to see here is a simulation that features a system for detecting workpieces of different colors, and it sorts them via conveyor belt into three different storage bins. Components you're going to find on this model include two mini motors, five phototransistors, five LED light barriers, three solenoid valves, a compressor, and an optical color sensor. The dimensions are approximately 20 by 14 by 12 inches. It has a weight of just about 10 pounds. And again, as before, the 24-volt version has the relay board for motor polarity reversal and both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, the end user must provide the PLC and the programming that's used. And the 9-volt version, again, will come pre-wired to a pre-programmed robotics TXT controller, and you'll require one power adapter with that. We'll let this finish its sorting, and then we will move right along. Bingo. The next model we're looking at is the first of the factory models, and this is the factory simulation. And this, again, this combines the last four models that we just reviewed, which would be the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection. It combines those into one self-contained material cycle. And what you're going to see in the upcoming video, once we get past the title sequence, is a cycle that works essentially like this. Work pieces are first off stored in the automated high bay warehouse, and they're retrieved from the automated high bay warehouse by using the vacuum gripper robot, and then they get moved to the multi-processing station with the oven for the processing that occurs there. And after the workpiece has been worked on by that station, it is then sorted by color in the sorting line with color detection before it is again moved by the vacuum gripper robot back to the automated high bay warehouse for storage. Now, as we've already discussed the components of each of these models previously, or each of the substations previously, I'm not going to belabor it by restating them here, but I do want to mention the dimensions of this model as a whole. Now, again, as you can see, it combines these four individual models into one cycle, and because of that, it has a much larger footprint of approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending upon whether we're talking about the 24-volt or the 9-volt version. Now, keep in mind that due to these dimensions, the model can only be shipped flat as freight on a pallet. I also want to point out that as the factory simulation models can be in high demand, during certain times of the year, like as we prepare for the fall, do anticipate we could be talking about a couple week turnaround prior to this leaving our warehouse. Uh, A few other things to note: it is currently available in a 24-volt version, and I'm not sure, we may or may not have the 9-volt version right now. The 9-volt version would be wired to 5 robotics TXT controllers. And in the case of that one, it would require 3 power adapters. And again, as mentioned with all the other models, the 24-volt version will require the end user to provide the PLC, the programming, and any other hardware between the two. Now, before we move on to the next group of models, I do want to mention that there is a storage option that's available specifically for users of either of the two factory simulations, the 9-volt or the 20-volt or 24-volt version, excuse me, that we've just discussed, or a few that we're going to be looking at a little later in the presentation. Essentially, it's to be able to protect the model when not in use, or of course, to add protection to it when it's being transported. Now, the travel case, as you see here, consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights, and this will help to cushion the model. And it also has 3 internal zipper pockets for storing cables and work pieces and all the other accessories that you have with the factory. The lower portion is lined with a hard foam, and it's really designed so that once the top section of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case itself has exterior dimensions of approximately 41 by 33 by 17 inches. It has a weight of approximately 53 pounds. Do note, though, that even when using this travel case, we still always suggest that the models are always shipped flat on a pallet just to adequately protect them from any kind of damage in transit. So just know that moving forward. And speaking of moving forward, the next group of models we're going to look at focused specifically on the area of IoT. And these are the Training Factory Industry 4.0 models. And this group of models was designed to help address how the recent changes in industrial production, which were of course driven by digitization, have created a need for stronger networking and more relevant information on all production levels. So with this Industry 4.0 update of the pre-existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale, of course, before they're implemented on a larger scale. Now, as the following video has a really nicely narrated overview of just how the factory works and the different components, I'm going to step back for a moment and allow you to watch and listen to the narrator. So here you go.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Okay. So just to summarize things quickly, here are some of the topic areas which can, of course, be addressed with the fischertechnik Training Factory Industry 4.0. First off, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models we previously discussed, perhaps most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. Of course, the use of NFC chips in each workpiece enables the positions of the workpiece in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the network TXT controllers to communicate with each other. Now, in regards to the 24-volt version specifically, I should note that it's a bit of a hybrid in that while it does require a PLC for operation and control, it does also incorporate one fischertechnik robotics TXT controller. And in this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communications between the PLC and the TXT controller are carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is of course a standard for exchanging data amongst different platforms like this. Now, in addition to the TXT controller that's used here, there's also an IoT gateway using Raspberry Pi with Node-RED. And this allows for the operation not only of, or the option not only of presenting and using data on a dashboard in the fischertechnik cloud, but also being able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC, and these, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM, pulse width modulation, and they also have push-pull output stages for phototransistors and for buttons. Now, unlike the previous 24-volt versions, the 24-volt models that we've discussed, the new 24-volt Training Factory Industry 4.0 does, in fact, include access to a sample program. Now, in the case of the sample program, it was written in structured text format, ST format, and it was created based upon a Siemens S7 1500 PLC, and this is available for download from GitHub. Now, of course, the training factory can also be controlled with other PLC models and brands, as I mentioned before. And to do that, the end user would need to make adjustments to the sample program. And for doing this, the source code needed is also available for download from GitHub. Now, all of this information and much more is included in a 152 PDF manual, or excuse me, 152 page PDF manual, which can be downloaded from the fischertechnik website, and it's available from us directly upon request. Of course, I'm going to provide information on, again, if you want that or any of the other things I mentioned along the way, you will be able to reach out to us. I also need to mention that as of last year, there are two additional versions of the 24-volt model which are available, and we're going to discuss those two options when we provide an overview of the costs of these models in just a few minutes. Now, in the case of the 9-volt version, the control of the model is facilitated through the use of 6 robotics TXT controllers. And again, with the case of the 9-volt version, all the programming is preloaded so that essentially once the connection to the internet and the cloud-based dashboard is made, all of which are clearly outlined in the downloadable documentation PDF designed to accompany specifically this model, once you've done that, you should essentially be able to get started. In the case of this one, though, you will need 3 power adapters to use with it. It should also go without stating when we're talking about any of these models that use the internet, this requires the end user, of course, has the ability to access the internet and as well as having a tablet or some sort of device for accessing the cloud-based dashboard that we keep talking about. Just to finish things up, the dimensions for these models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds, depending on the version. And as with the 2 factory simulation models that we discussed previously, we do recommend the optional travel case, which we looked at a few minutes ago, to help protect the model during travel or storage. And that is the Training Factory Industry 4.0 model, again available in both 9-volt and 24-volt versions. We do have more models to talk about. The next one we're going to look at is one that incorporates the cutting edge technology that's quickly becoming a part of our daily lives, and that's AI. This is called the Quality Control with AI System Model from fischertechnik, and it's ideal for visualizing this complex subject area in a hands-on manner, and it creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation can be standardized. The fischertechnik sorting line comes with work pieces in three different colors, much like you saw before, but in this case, the work pieces are marked with three different processing characteristics, as well as various fault patterns. Now, what would happen is when you put the work piece on the conveyor, it's first off scanned by the camera, and then it's classified with the aid of the trained AI. Now, depending on the color, the feature, and whatever fault pattern may be on the piece, the work pieces are then sorted by the artificial intelligence on the basis of the quality features. The AI used is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the fischertechnik TXT 4.0 controller. The model sequence control is implemented in the RoboPro coding programming environment and also in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications, and in this case, the training is done in Python, for which a sample project is provided for explanation. And that is the quality control with AI model. It's an ideal training simulation and demonstration model for education and research and the visualization of AI-based systems, machine learning, and neural networks. It's available only at 9 volt at this time, and it uses the fischertechnik's robotics TXT 4.0 controller, and so you're going to need one power adapter with this model if you get it. Now, the next model we're going to look at is a recently released model. It's called the Agile Production Simulation, and it's the very latest version of the factories that we've been looking at, but this time not only incorporating IoT and state-of-the-art manufacturing processes, but also bringing the AI element in, as well as a digital learning platform. Now, this factory of the future is, of course, the subject of numerous research projects in science and industry. Forward-thinking companies that rely on automation, modularity, artificial intelligence, and agility, all to remain competitive. Now, in order to promote these topics in industry and research, students, apprentices, as well as employees all require the corresponding know-how and awareness to enable them to deal with these complex issues. And this is where the learning concept of the agile production simulation model comes in. What it does is it simulates processes such as quality assurance using artificial intelligence, much like what we just looked at in the previous slides. It incorporates the functioning of driverless transport systems, and it replicates automated processes on a small scale, from goods receipt to modular production to quality assurance. The accompanying materials will help to translate the hands-on simulated processes into future skills for both students and teachers. And the digital twin that's included of the model significantly intensifies the learning experience that you're able to achieve here. Now, as we don't yet have a narrated video of this model, I'm going to provide you with a quick overview, beginning with the module where the incoming and outgoing goods would be placed in this. And that is, of course, really where the material flow of the workpiece begins and ends. What happens here is that raw material is delivered at the goods receipt slot. It's positioned on the color sensor for quality control using the 6-axis robotic arm with a vacuum gripper, and then it's encoded by the NFC reader. And I will mention here that's a 6-axis robot that's unique to this model. It's only with this model. The previous versions we looked at were 3-axis. Continuing on, the robot then places the workpiece on the automated guided vehicle, or as we'll call it, the AGV, for further transport. The module also contains the central control unit, which is a Raspberry Pi, and the environmental sensor, which again measures different environmental conditions on the factory, things like temperature, air quality, etc. There's also an integrated movable camera, which can be swiveled in two axes and provides an insight into the entire factory via the fischertechnik Cloud dashboard, which again, we just saw examples of in the previous factory video. Now, at the end of a work cycle, the finished workpiece is delivered back at this station by the AGV, but this is again where it will start off. The next stop, commonly for a workpiece, of course, it can be changed because this is an agile production simulation. So you could change the order of the workstations that each piece needs to go to, how it needs to go there. That's going to be your call. But essentially, the way it's initially set up, the first stop would be the high bay warehouse. Uh, so basically, the high bay warehouse again contains 9 slots for work pieces. It contains a stacker crane and a vacuum gripper that picks up the work pieces from the AGV. So it has its own vacuum gripper that picks up the piece from the work or from the AGV, the automated guided vehicle, at the docking station, and it hands it over to the stacker crane for storage. The workpiece is then placed in a workpiece carrier for storage, and retrieval is done according to the first in, first out principle. Next up, it will commonly be the drilling station. And the drilling station consists of a docking station for the AGV, the automated guided vehicle again. It has its own vacuum gripper that again takes the workpiece from the vehicle, moves it onto its own conveyor belt where it's transported under the drilling head. The simulated drilling process takes place. The workpiece then gets transported back to the vacuum gripper that's at this station on the conveyor belt, and then the gripper picks up the piece and moves it back into the AGV for transport to the next station, which in this case will be the milling station. And this again has another docking station here for the AGV to hook up to. It has its own vacuum gripper that again picks up the workpiece from the AGV, moves it onto the conveyor belt that this station has from where it's transported under the milling machine. The process of putting these two simulated pockets is performed, and after that process is done, the workpiece goes back onto the conveyor belt, transported back to the gripper. Robotic gripper picks up the piece, moves it back into the vehicle. Now, the next station would be a quality assurance module, and this is, again, a variation of what we just looked at with the standalone model. Here, a vacuum gripper places the workpiece on the conveyor belt again. It's transported underneath the camera and scanned there. Again, the workpieces come in 3 different colors, red, white, and blue, and they have 3 machining features printed on there, either drilling, milling, or drilling and milling, as well as various fault patterns. In this case, they're all classified by the trained AI. Now, depending on the color, the feature, and the fault pattern, the workpieces are handled one of 2 ways. They're either placed back onto the AGV as being okay, or they're sent to a reject container as being not okay or defective. And then the AGV that I keep mentioning, the automated guided vehicles, of course, what transports the workpieces from one workstation or one module to another. It's essentially a track-bound vehicle that follows the printed black tracks that are printed on the factory floor. It uses ultrasonic sensors to detect obstacles that might be in its way. The vehicle itself has omni wheels, which allow it to move in all directions. 2 buttons and a photo transistor help the vehicle dock to individual factory modules, and the AGV receives its driving command from the central control unit, which is an industrial standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. And speaking of the battery, when the battery of the AGV runs low, the vehicle navigates towards the charging dock where it is automatically charged with a charging unit with charge monitoring. Contacts on the bottom of the charging station connect with the AGV and its charging electronics. So moving right along, we're going to quickly review some of the technical aspects. You have a 24-volt supply unit, 11 amps. Power supply unit, I should say. Central control is by a Raspberry Pi 4B. The individual modules of each of the workstations are controlled with the help of 5 different Siemens S7 1200 PLCs. So each of those individual workstations I talked about here, whether it be the high bay warehouse, the quality control module, the milling station, etc., each has their own Siemens S7 1200 PLC connected. Additionally, the model includes three fischertechnik TXT 4.0 controllers, which are used to control the sensors and the camera, as well as to facilitate the cloud-based access in the WEA module for quality assurance with AI, as well as for the automated guided vehicles. And of course, has a WLAN router for WLAN network. Software used in the APS model include SPS programs, structured text for the PLCs, TypeScript, for the central control of the Raspberry Pi unit. You have Node-RED for communication between the SPS and the fischertechnik TXT 4.0 controller, Python for programs on the TXT 4.0 controllers, and TensorFlow for supervised learning and quality assurance with AI. Now, again, as I mentioned, there's also a digital learning platform with a digital twin of the APS model, and this will help so that learning can be done with both the actual model as well as in a virtual environment. Now, as there is really a lot of detail to cover on this model, if you would like to know more, I strongly encourage you to sign up for our next webinar, which focuses specifically on the Agile production simulation model, and it gets into a bigger discussion of why the model is useful, but this kind of, for now, gives you an overview of that. Of course, I'm sure Christy will send you information on the following webinar if you haven't received it already. So look forward to that. So at this note, as we're coming to the end, you probably are wondering, what do these things cost? So we're going to take a quick review of each option that we've discussed along with the pricing for each. First is the conveyor belt in the 24-volt version. Again, requires PLC programming, etc. That is a cost of $359.95 per unit. The 9-volt version that comes pre-wired to the TXT controller is $518.95. The punching machine is no longer available. The indexed line with two machining stations in the 24-volt version, this will require a PLC in the programming. It's $1,199.95 per unit. The 9-volt version, which comes pre-wired to two TXT controllers, is $1,394.95. Again, these are both in limited availability now. It's what we have in the warehouse. So if this is something you're interested in either version, this is the time to act. These will probably be gone by the next presentation. 3D robot in the 24-volt version, it is $1,094.95. Again, it requires the PLC and the programming. 9-volt version attached to the TXT controller is $1,369.95. The vacuum gripper robot, 24-volt version, again requiring the PLC and the programming, $1,199.95. No 9-volt version available. Automated high bay warehouse is available in the 24-volt version, requires the PLC, the programming, $1,448.95. 9-volt version, $1,318.95, of course, pre-wired to the TXT controller. Multi-processing station with oven in the 24-volt version, you're talking $1,287.95. The 9-volt version with the TXT controller is $1,474.95. Sorting line with color detection in the 24-volt version, $1,126.95. In the 9-volt version, I think it's $1,128.95. One of those digits is off, but essentially that's essentially the same price. The factory simulation, yes, this corrects me. The 24-volt version is the only one available right now. The cost for that is $5,299.95 per unit. The Training Factory Industry 4.0. In the 24-volt version, this, of course, requires the PLCs and the programming, etc. Or there is a sample program, but the PLCs are required any additional wiring. The cost for that is $9,659.95. The 9-volt version, which comes pre-wired to the 6 robotics TXT controllers, that's also $9,659.95. But as I mentioned, there are two additional versions that are available now. There is a version that includes the PLC connector board and all of the cabling and what have you. What it doesn't have is the PLC. This version is $12,879.95. This is, of course, the 24-volt version. And There is also a variation that does include the PLC. In this case, it includes the Siemens S7 1500 PLC. Uh, so this is pretty much the everything you need in one package if you're looking at the PLC-based version. Uh, the cost for this is if you're an educational institution ordering, this is $19,639.95. If this is for commercial users, the cost is $20,124.95. Again, this includes the wiring, the PLCs, the whole nine yards. So again, with just the connector board and the wiring, $12,879.95. Or if you want the version with the Siemens PLC, the S7 1500, again for education, $19,639.95. Or for commercial users, $20,124.95. Other items, we touched upon the power adapters I kept bringing up. Those are $12.99 each, so you don't need more than three for any of the models, so it's not a terribly costly thing. The travel and storage case for the factory simulation and training factory industry 4.0 models. So any of the three versions of the training factory, or of course the factory simulation, and the cost for the case is $1,524.95. The quality control with AI, again, it's only available in a 9-volt version that comes pre-wired to the pre-programmed robotics controller. Cost is $2,249.95. You'll need a power adapter. No 24-volt version available. The Agile Production Simulation, which we saw at the end of the presentation, this is a 24-volt version only, of course, and the only variation is the one that includes everything. So the 5 Siemens S7 1200 PLCs, 3 TXT 4.0 controllers, plus the digital twin. The cost for that is $28,174.95. There is a storage option, the Agile Production Simulation storage case. It's a two-tier case. Cost for this is $4,024.95. Hang on just a second here. What we're going to be looking at here is, again, this is a much larger case. It's a two-tiered variation of the case we previously looked at for the other factory models. And this is, of course, designed to house the various components and modular sections of the APS model when they're not in use or when in transport. And again, we recommend that all factory models, and especially this new model, that whether, that you're always going to use these cases and ship them flat. This case is especially important for the APS model because the APS model comes apart in sections. As you see that part of the floor of the factory, it comes apart in sections like that, so you really want to use this. The case has an aluminum case maker profile with plastic plates. Each of the two separate case sections has steel tilt handles and angle protection corners for additional stability. And there are also straps and additional internal zipper pockets for storing the cables, the cords, the workpieces, other accessories. The lower section of each case is lined with hard foam, while the upper sections have some foam to help cushion the various work modules while in storage. Again, cost is $4,024.95. And wait, there's more. Just to touch on a few other things, there is now a standalone 6-axis robot that's available. It's only available in a 9-volt version, comes pre-wired to the TXT controller. You're talking $1,599.95. There is no 24-volt version on that. There is a new model, the 24-volt version of a production line. The cost for that is $1,599.95, and this does come with a PLC programming course. So that may be of interest. Of course, you have to provide the PLC and the additional wiring for that. And there is also a bending machine, 24-volt version for $799.95. That also comes with the PLC programming course, which is a nice little feature. Essentially kind of a digital twin with either of these last two models as well. So that's kind of important to consider. Again, you provide the PLC and the programming. There's also two APS add-on modules. You can add on an additional AGV vehicle, so you could have potentially two vehicles on the factory floor at any given time. If you want to do so, the cost for that is $2,249.95 for an additional AGV. Or there's an additional station that can be added in. In this case, it's an annealing furnace that can be added in. The cost for that is 3,859.95, and you'll see that does include the Siemens PLC with that as well. So this is the point where normally I would have folks ask any additional questions, but as we're running late, we're going to move this right along. So if you would like to take the next step, and perhaps that means requesting our 2025 Higher Education Industry Guide and current pricing, if you'd like to ask any questions directly, if you'd like to receive a quote or speak with your dedicated educational representative, you can do so by calling us at 888 561 7521. That's our toll-free number here in the U.S. General questions can be emailed to info@studica.com. If you have any specific questions for me, or if you'd like to receive any of the documentation I mentioned during this presentation, you can contact me directly at lance.zurich. That's lance.zurek at studica.com. So on that note, thank you very much for taking the time to attend today's presentation. We look forward to hearing from you soon. Have a good afternoon.